Yeah, hi everyone. Uh, Hope you all are fresh enough of taking this mathematics session. We have been attending classes of English before this, so you might have had a little bit of fresh air. And let's start our data interpretation. When we talk about data interpretation, it's nothing but data is what? Some information that we gather and organize it and put it on paper in a digital format and then store it. That is data. Okay. So if you interpret means analyze it, whatever you call. So that is called as data interpretation. So let us see what way we want to interpret our data. So now if you look at this, here is a graph of the number of new species found in different continents in the year 2000. NA means North America, SA means South America, EU means Europe, AS means Asia, AF means Africa, AU means Australia, AN means Antarctica. You can see here. NA, North America, it is 10, 20, 30, 40 units. Okay. So then South Africa, South America, sorry, not Africa. South America, 1, 2, 3, 4, 5, 6, 7, 8, means 80 units. Each one unit is 10 units. Okay. Europe, 20. Asia, 40. Africa, 6 plus 1, 7, 70 units. And Australia also 70 units. And Antarctica it is 10 units. This is what is the data that is given. See, in these type of cases, if this is some printed format, that would have been easy for us to discuss. But every time we discuss a question, we need to move the screen up and down. So I want you to bear with us if something like this has to happen. It will happen. Compulsory, it will happen. Therefore, you need to bear with me. So let's see now what is the question that he has asked. How many species are found in Australia? So I think it is 20 if I'm right, if I remember correctly. Australia, no, not 20, sorry. 1, 2, 3, 4, 5, 6, 7. 70 species. Okay, 70 species. It's there. So Australia, 70 species. Then next, yeah, it's option A. So according to the data, it is 70 species. The option is A. This is what we discussed. So of course, instead of moving, I think you understood it's very simple logic. You just need to keep on moving, I mean, the screen up and down to get there, but instead of that, the information is already tracked here. So you can look at it. So this is the diagram again. The second question. What is the number of species found in the year 2000? So here numbers are given. First 40, next is 80, next is 20, 40, 70, 70, 10. Add all these things, you'll get 330 species. That is option B. Okay. So this data, whatever I'm reading from here, is found in the graph. You can just see this. Okay. The previous graph, whatever we did, that shows the information that I'm talking about. Okay. So now next, again, he has given the, we have given the graph here once again, whatever we discussed before. You can see here 40 plus 80 plus 20, 140 plus 40, 180, 180 plus 70, 250, 250 plus 730, 70. So that is 320 and then 10, 330. That is over. Now let's see what is the next question. Third, what percentage of new species is found in Europe? He gave something. So Europe's should be 20 divided by total. We got it as 330 just before into 100. That is 6.06. That is option C. Okay, children. So please go with fast. Yes, children, let us go to the next question. Again, the graph, which we have already seen before. So let us see the question now. In which continent approximately 25% of the species are found? So he gave this. So 330 means it should be the one with 80 approximately. Okay. So 25 percentage of 330 is 82.5. So that means nearest to 82.5 is 80. So the continent uh, with 80 percentage is the right answer. So it is South America. Option B. Please note it fast. Right, children. So let us go to the next question. Yeah, look at this. Alexandra started walking to her friend's house. She stopped to call. Uh, yeah. She stopped to call and wait for an Uber car. Uh, then she took the car to her friend's house. If the total trip took 45 minutes approximately, how many minutes were spent in the car than were spent walking? Alexandra started walking to her friend's house. She stopped to call and wait for an Uber car. Then she took the car to her friend's house. If the total trip took 45 minutes approximately, how many more minutes were spent in the car than uh, you spent walking? So look at this. Total distance covered is 10 meters or kilometers, what it is, whatever. Yeah, this is time. In fact, this is time. And distance traveled is maybe meters or kilometers, what it is. It's not mentioned here. But remember, children, in any examination, if at all he gives some data, he'll mention the units also. Maybe here we missed the units, but in actual examination, there will be mention of things. So sometimes human error happens, so here it is something like that. So for first 10 minutes, she walked, and after that, there is a constant, some amount of distance, time. It is the waiting time. This is called as waiting time. There is no change in distance. Horizontal line means there is no change in distance. That means this is the waiting time. She waited for almost 10 to 25, means 15 minutes she waited. And then she started moving in the car. So the travel time for that is This each one is 5 plus 10, 15. 15 plus 5, 20 minutes she went in the car. 15 minutes, 20 minutes she went in the car. 20 minutes is car, and 10 minutes is walk, and this is 10 plus 5. 15 minutes is waiting. So 15 minutes is waiting. So total time is 20, 30, 45. Okay, that is what he said, you see. 45 minutes. Okay, now let us see what are the things that he has asked. So he's asking about spent walking. Spent walking. What is walking time? 10 minutes. So therefore answer is B. Option B is the answer. Please note it fast. Please note it. Okay, so let us go to the next question. The graph below shows the number of households in hundreds in any town, USA, with internet access by household income in thousands. Also shown is the line of best fit. So line of best fit is this. This is the line of best fit, starting from here to here. This is the line of best fit. You can find a line there. So now what is that? He says, this is household income. Okay. And this is households, hundreds. So the graph describes, shows the number of households in hundreds. Means if I say 10, 10 into 100. Let's say 20, 20 into 100, like that. Okay. With internet access by household income. Based on the household income, we are deciding how many uh, people are having internet and how many are not having. So this is what is the thing. So now look at this data. So there are certain 1, 2, 3, 4 points. So that means they are below the best fit line, and there is only 1 point above, which is above the best fit line. So that is 35,000, 3,500, sorry, not 35,000, 3,500 households are above the best fit line. On the best fit line, there is no one. Okay. Look at the question. So this is the graph again. Whatever we have done with, whatever we have seen, the same graph. So now how many households with an income of 1,50,000, 15,000, 15,000 is this, can be expected to have internet access. So drop a vertical and this line, vertical line, and this line, if you drop, it is somewhere here, somewhere here. So it is approximately 1,500 plus, 1,500 plus. So that means approximately it is 1,500, little above. So that little difference, if you neglect, it is 1,500. So option C. Okay. On the line, if you check, it is 1,500. Okay. Please note it fast. Okay, so let us go to the next question. Questions and refer to the following information. So this data is given. So here he has mentioned years. So every one box, if you take, it is showing 10 years, right? So that means this should be 1940. The first one should be 1940. Okay, the first one should be 1940. So each of them is 1 unit. So this is 4 units. So in 1950, it is with 4 units. What is this? Enrollment in thousands. So 4,000, like that. It is decreasing. Enrollments have decreased. From 1950 to 1960, enrollments have decreased. Okay. From 1960 to 1970, enrollments have increased heavily. So you see the steepness of the line. So the rate of increase or number of increments are very high between 1960 and 1970. After that, there is increase, but the rate of increase is low. This again increase from 1980 to 1990 also it is increasing, but not as much as 1960 to 1970, but more than 1970 to 1980. Then afterwards, uh, from 1990 to 2000 also it is increasing, but lesser than between 1980 to 1990 or 1960 to 1970 and almost equal to that of 1970 to 1980. You see, this is the midpoint. This is also the midpoint. Means this is from some fixed number, that is an integer, to 5.5. So here it is 6.5 to 7. So the rate of increase is same. Please observe and analyze the graph perfectly. So that means rate of increase here and rate of increase here is same. That means this is highest, second, third, and third as per the rate I'm talking about. Then as far as the understanding with the values that are observed. So now we should see what is the question and is anything connected to the rates he's asking or something else we need to check. So this is year and enrollments in thousands into the college. Okay. This is 3.5. 3.5 to 1,000 is 3,500, like that. This is 4. 4 into 1,000 is 4,000 enrollment, like that. So this is how the understanding of the graph goes. The line graph above shows the enrollment for the college are between 1950 and 2000. 1950 and 2000. That is clearly seen. You see 1950 and 2000. Okay. Now, what is that he's asking? So look at this. According to the graph given, college are shown the greatest change in enrollments between which 2 decades? This we have talked on. Yes, that's what we have discussed. So, we have put 1. Greatest, increase in the enrollments is between 1960 and 1970. Between 1960 and 1970. So, look at the answer. 1960 to 1970. Option B. Okay. This is what we have discussed before. So, 1990 to 2000, it is same 50. Same like this one 500 increase. So there also between 1990 to 2000, again it was same 500 increment. Okay. So therefore, this is the data. So what we discussed before, it's same. So from that data, you see the greatest increase is between 1960 to 1970. Right, children? Please go to class. So even 1990 to 2000, it's same 500 increase. Okay. Right, children, hope you have copied. Let's go to the next question. You see, there is some information given. So here, what is this? Same, the previous information that I'm seeing here. There is no change. So here it is decreased. This enrollments in thousands, so therefore it is 500 decrease. Then here it is 1000 plus 500, 1500 increase, and it is 500 increase. This is 1000 increase and 500 increase. So look at this. This is 500 decrease. A line is sliding down means it is decreasing. Sliding up means increasing, like that. Okay. So this is it. The line graph above shows the enrollments for college are between 1950 and 2000. So that is okay. So this is 1940, which is not including anywhere in the discussion. So let's not bring that into picture. So now what is the question? What is the average rate of increase in enrollment per decade between 1950 and 2000? So what we should do, average means sum of all the terms divided by number n. Okay. So first there was decrease of 500, so minus 500. Then next there is increase 1500, if I'm right. Okay. Then next 500 increase. Then next 1000 increase. Then next 500. So how many decades are there? 1, 2, 3, 4, 5 decades. Okay. So therefore you are getting 2000 plus 1, 3000 by 5. That is 600. Average increases 600 between 1950 to 2000. So please note it fast. Okay, let us go to the next question. So look at this. Question 9 refers to the following information. Again, it's the same information. What we have seen, so there is no need for to read, but just to repeat, it is decrease of 500, increase of 1500, increase of 500, increase of 1000, increase of 500. So this is the data. So this is same, so it doesn't matter. Now, question is important. If enrollment increases by approximately the same percentage between 2000 and 2010, as it decreased between 1950 and 1960, what is the expected enrollment in 2010? So, if the decrease in 1950 to 1960 was 500. So, what is that he said? The same percentage between 2000 and 2010 as it decreased between 1950 and 1960. This is very important. This, okay, this is percentage he's talking about, not number. Okay, so now let us see what is it. He said, now he's asking me what is the strength in 2010. By 2000, it was 7,000, isn't it? You look at this. Okay. So now, 1960 number decreased is 500. By original number was 4,000 at that time. So 500 by 4,000 is 0.125. So the percentage is 12.5. Percentage is 12.5. So increase should also be 12.5. So that means expected increase is 12.5. So that means what was the strength uh, in 2000? So it is 7,000. So number of increase is X by original number is 7,000, that is 0.25. So X is equal to what? 7,000 into 0.25. 10,000 into 0.25 is 875. So that means the strength in 2000 was 7,000 plus increase is 875. So therefore, the total strength in 2010 will be 7,875. Right, children? So please note it fast. We'll go from the previous page. So this is the page from where we need to start our noting. Please note it fast. Yeah, please note it quick. Then I'll go to the next page, then to the next page. Right, children, let us move to the next page. Please note it fast, quick. Okay, let's move to the next question. Paul, Mikhail, and Bobby are computer salespeople. In addition to their regular salaries, they each receive a commission for each computer they sell. The number of computers that each salesperson sells during a particular week, as well as their commission amounts, is shown in the tables shown. That means different people may have different commissions. That's why a tabular form is shown. Look at this. Peter, on Monday, he sells 9 computers. Mikhail sells 6 computers, and Bobby sells 8 computers. On Tuesday, they are the numbers. Okay. So against them, what is the commission that is paid using? Peter is paid $15 per computer he sells. Mikhail is paid $20 per computer he sells. And Bobby is paid $25 per computer he sells. Now, we know the numbers of each person in each on a day of a week and the amount that they get. Suppose, for example, Monday Peter is selling 9 computers. So apart from his regular salary, he'll be paid an increment of, a commission of 9 into 15. So this is $135. Means he's earning $135 as commission on Monday. Like that. You need to check what is the question he was asked. Okay. Look at the question. What is the total amount of commissions that Bobby earned over the entire week? So Bobby's day-wise sale, we should see. Sum of all day-wise sales, and the number and the amount per computer he gets. So, what is that Bobby sold? 8 on Monday, 4 on Tuesday, 5 on Wednesday, 7 on Thursday, and 8 on Friday. The total computers he sold is 32 computers. And per computer, he earns a commission of $25. So 32 computers, it is 32 into $25, which is $800. So he earned $800 in that week. Okay, it is option A. Please note it fast, quick. Okay, let us go to the next question. Again, it is the same data. There won't be any change because the question mentioned are same, so it is the same. Okay, the only question will change. So let us see what is that question. What is the total amount of commission money that is paid or earned by Peter, Mikhail, and Bobby on Thursday? So vertically, it was Thursdays was it is like this vertical Thursdays. Okay, this is Peter, then Mikhail, and Bobby. So if you take sum of all these three, you'll get total number of commissions. I mean, computers sold, but as each one has different commission for the, I mean, the computers they sell. So we need to take Peter into his commission, plus Mikhail into his commission, plus Bobby into his commission. So this is what is the method we'll follow. So look at the options are there. So on Thursday, Peter sold 6 computers. So he earns $15 per sale. So he earned $90 on Thursday. Okay. Now similarly, if you take Mikhail, he sold only 1 computer on Thursday. So he'll be earning $20. And then Bobby sold 7 computers on Thursday. So he'll be earning $175. What is the total earning that all three together did? 90 plus 20 plus 125, 175, sorry. So this is 5, 9 plus 9, 18, 285. So this is the total amount earned by all three together. So option A. Please go to fast. Okay. So let us see what is there next for us. So again, the same data, but it's all same. So let us see what is the question. Okay. On what day did Peter and Mikhail earn the same amount in commission? So look at this. Days he gave. So their earnings are what? 15 is to 20. So 3 is to 4. So their sale should be in the ratio of 4 is to 3. Then they'll be equal. Okay, because 4 into 15 is 60. 20 into 3 is also 60, like that. So the number of sale of computers should be in the ratio of 4 is to 3. Therefore, check in which day of the week they have in the ratio of 4 is to 3. So if you look at this 4 is to 3 ratio, so Peter earned on Monday 9 into 15, that is 135. This is all not required. We'll just take this. You see, Peter is selling 12 computers on Wednesday, and Mikhail is doing selling 9 computers on Wednesday. So this is 4:3. That's what I was saying. So you should take the, see, earnings was in the ratio 3:3, 3:4. Earnings are in the ratio 3:4. So sale of computer should be opposite for them to be equal. So this is 4:3. So therefore you are getting 12:9. I mean 12 computers by Peter and 9 computers by Bobby, and their earnings are 180. So option is C. So please note it fast. Okay. So let's go to the next question. Question 13, refer to the following information. So information is given below. So shows the discount percentages for various categories of items at Williams department store and the regular prices for 3 specific items. So discount amount during sale. Furniture, it is 20%. Clothing, it is 15%. And electronics, it is 10%. So these are the first discount percentages during the sale. So regular prices. What are the regular prices? Desk 350 means furniture. Desk means furniture. Okay. Clothing, shirts 20, and electronics, television is 180. So these are regular prices. Of that, we should give discount. Suppose if it is furniture, I should give a discount of 20%. Means discount amount will be 20 by 100 into 3. So what should be the discount? So 35 into 70, like that. This is how we need to calculate all the discounts of everything. So that means the desk, if he purchases, he'll get a discount of $70. So it will be 280 will be the actual price, selling price, okay, after discount. So let us see what is the question. Similarly, clothing and other things, okay. So now let us see what is the question that is asked. What is the price of television during the sale? So now what is the discount that we are getting? 10% discount. So what is the actual value of the television? That is $180. So 10% of 180 is $18. 10% of 180 is $18. So what should be the selling price? Actual price minus the discount. So that is nothing but $162. So we have option D. So please move it fast. Question. Okay, children, let us go to the next question. Look at this. Question refers to the following information. So this is same. Williams department means everything is same as it was in the previous case. So see, the discounts and the prices are same. Okay. Now let's move to the question. So this all we have already discussed. So no need to discuss again. If Tom buys a shirt and a desk during the sale, how much money does he save? So that means sum of discount. Sum of discounts is the money he saved. So now, uh, on desk, there is 20% discount. On desk, it is 20% discount. So 20% of 350 is $70. So he saved $70 on desk. Now on shirt, you see, it is 15% of total price of shirt is $20. So 15% of 20 is free. So total money he saved will be $70 plus $3, which is equal to $73, which is option C. So please note it fast. Okay, let us go to the next question. Question 15 refers to the following information. It is same, so there is nothing we need to do extra. All the thing what we did was same before. The only thing is we need to see the question and work out that question. During the sale, how much greater is the savings on a television set than on a shirt? See, what is the saving on television? It is $18, 10% of this one, $180. So on shirt, they saved $3. So what is the difference of saving? 18 minus 3, that is 15. So option C. Please note it quick. Yeah. This data is different. Question refers to the following. Hours were Miss Jack and Miss Matthew. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. These are the hours they worked. Okay. So salary scale, dollars per hour. Miss Jack, it is 18. Miss Matthew, it is 11. So that means the amount of money Miss Jack earns on Monday will be $64. Like that. So let us see what is the question. During 1 week or during week 1, Miss Jack worked how many more weekdays, Monday through Friday, hours than Miss Matthew worked. So total number of hours worked by Jack minus total number of hours worked by Matthews should give you the answer. So if you add all the work hours per day of Jack, we are getting it as 37 and a half. And Miss Matthew, we are getting it as 31. So the difference is 6.5 hours. So option is D. Please note it quick. Okay, let us go to the next question. Question 17 refers to the following information. It is same as the previous one. So let us go to the question. If Miss Jack is a manager and manager earns an extra 1.50 per hour per weekend, that is Saturday and Sunday's work, how much money did Miss Jack earn on Saturday and Sunday? So let us say the total working hours of Jack on uh, Saturday and Sunday, but total money she can earn on those 2 days is $8 is her actual pay and $1.5 is extra. So total $9.5 she'll be earning on those 2 days. So she worked for 7 hours on those 2 days. So total earnings that she can make will be 9.50 into 7, which is 66.50, which is option D. Please note it quick. right? Let us go to the next question. Look at this. So it's same data, same information. So let us see what is the question. So how much more money did Matthews earn on Thursday than Miss Jack? So we have to work out the total money earned by Matthew on Thursday, Miss Matthew on Thursday, minus the total money that Miss Jack earned on Thursday. So Matthew earns $11 an hour and she worked for 6 hours on Thursday. So total she earned on Thursday $66. Same way, Jack earns $8 per day and she worked for 6.5 hours on Thursday. So total money she earned on Thursday is $52. So the amount of money Miss Matthew earned more is 66 minus 15, which is 14. So option B. Please go fast. Okay. Okay, children, let us move to this. Question 19, referring to the following data. Yeah, here data has changed. Some new data has been given. So in an election, Harry and Charles were the only one who received votes. So number of votes received by them in each district is mentioned here. What percentage of the votes cast in District C did Harry receive? So Harry received 450 out of total votes is 750. Okay. So what should be the percentage? The amount of votes which Harry received divided by total votes into 100. So that is 450 by 750 into 100, that is 60%. So option C. Please note it fast. Okay, let's go to the next question. Same data. So let's go to the question. What is the ratio of total number of votes? What is the ratio of total number of votes received by Charles to the total number of votes received by Harry? So this is very simple. Take the total votes received by Harry and Charles and total votes received by Harry. So the ratio of them is 1000 is to 900, that is 10 is to 9. Okay. Please note it fast, quick. Let's go to the next question. Yeah. This is the data. The minimum age requirement. Question 21, refer to the following. The table shows minimum age requirement for obtaining a driving license, ages and number of states. Okay, so let us see what is the question. So the table shows the minimum age requirement for obtaining a driving license or driver's license. In what percentage of the states can a person obtain a driver's license before the age of 16? So look at that. According to the given table, a person can obtain a driver's license at 14 years of age in 7 states. 14 years of age in 7 states. And at 15 years of age in 12 states. So total is 7 plus 12 number of states, that is 19 states. So that means we can get the license below age of 16. So total number of states that we have is 50. So percentage of those states which can get license below 16 years of age is 19 by 50 into 100. So that is 38%, option C. So please note it. Okay. So let us see the next question, children. So now look at this. This is another data here. Growth of laptop computers in US households. So if you take x-axis from 2010 to 2014, they gave data. Okay. In 2010, the increase of computers number of households in millions. So 40 millions. And in 2011, it is 55 millions. And in 2012, it is 65 millions. And 2013, it is 80 millions. And 2014, it is 100 millions increase. Okay. Not increase, but number of computers that each of the households have. So let us see what is the question. The question number 22 refers to the graph above. So the graph above shows number of US households with laptop computers for the year 2010 to 2014. That is fine. What was the percentage of increase in the number of households with laptops from 2010 to 2014? So that is increase by total into 100. So 2010 to 2014, then 2010 it was 40 millions, and 2014 it is 100 millions. So amount of increase by original amount into 100. Amount of increase is 100 minus 40 by original amount is 40 into 100. So that is nothing but 60 by 40 into 100. They'll be getting it as 150% increase. So option is D. Please note it fast. Right, children, let us move to the next question. So the data is same. So question 23 refers to the above graph. So it is all fine. The greatest percentage of increase in the number of households with laptops occurred during which two consecutive years? So 2010-11, he gave the data. But if you look at the increases, 2010 to 2011, the amount of increase was like 15 by 14 to 100. So that is 37.5%. 37.5% from 2011 to 12. The increase was 18.18. So this is highest. So till now, in the first two cases, A and B options, if you take, 2010 to 2011 is higher. Okay. So now let us see if anything else will be higher than 37.5. Of course, these all we need to calculate because denominators change. You see, denominator is 40 and here it is 55 like that. So therefore, if these denominators would have remained the same, I would have just seen the increase and I would have decided. But as denominators change from case to case, so we need to find each of the case. 2012, 2013, the total percentage increase is 23.08. So still it is 37.5 is higher. So 2013 to 14, again it is 25%. So still 2010 to 2011, it is 37.5. That is highest increase. Okay. So option is A. Please note it quick. Okay, children. So let's go to the next question. I mean, topic is data interpretation 2. Same, it's same, but questions are different. So data interpretation 2 and data interpretation 1 will be same. There will be no change of concepts, so but the structures will be different. So here, if you see, this is a pie diagram. So in pie diagram, we are having certain percentages. So the figure shows the percentage of different price ranges of goods in a store. What percentage of goods cost more than $10? So this is less than $5. This is between $5 and $10. So this is the only zone where it is greater than $10. So he is asking about percentage of this part. He's asking percentage of that part. Okay. So now he gave options as 6, 12, 22, 45. So let us see what is that exactly equal to. So if you take more than 10 millions, this is the part. Okay. So this is a 90-degree part that we have taken. You can see the dotted lines and this. So we have to calculate using those things. So as shown in the figure, about 25% of the pie is 1/4 of the pie diagram. So that is understood because 25% means it is automatically 1/4. Okay. Since OE is this from here to here. That is OE. OE bisects AOD. So this AOD. So this is the thing. So this bisects. So that means if I take 50% of AOD, that is enough. 50% of AOD, that is enough. So therefore, the answer is roughly about, see, half of it is half of 25. This is 25%, 90 degrees, isn't it? I've shown the dotted line. The dotted line, it is 90 degrees. So roughly half of 25% is 12.5. So answer is B. Please go fast, quick. Right. So let us go to the next question. So in the figure, if the figure shows the percentage of different price ranges of goods in a store, so the same diagram. Now, what is the question? If there are 360 items in the store, cost less than $5, how many of them are with same sale price more than $10? So 360 items in the store cost less than $5. So we should see what is the percentage of, this one. What percentage of the items less than 5% are there based on $5 are there? Based on it, you can get the comparison. So EOC is little bit bigger than 90%. We need to go back to the diagram, but you can check it with yourself. The item sale price less than $5 is slightly more than 25% of the total number of items. So if you take presumption, say this is not exact data because he did not mention the correct value. So we should approximate the things. So as it is little higher than 25%, we are approximating it to 30%. So this could give little different answer than what exactly is happening. So it doesn't matter. We are only working on approximation. So it's okay. So 30% of the goods is 360. So 12% item with sales price is more than $10. So the total goods that are above $10 is 144. 144. So nearest value is 140. So that is option B. Please note it fast. The students should get a doubt. When I talk about percentages, there should be 100 each. So for 30, you'll have 1 by 100. For 12, you'll have by 100. Those two hundreds gets cancelled. Therefore, you're not seeing any of those hundreds there. Okay, so let us go to the next question. So let us see, there is a data given here. So this is number of employees to the time. Number of employees to the time. So let us see. See, that means what number of employees when they start is 5. You see, it is 5. The number of employees in 91 is 10, 92, 20, 93, 40, 94, 70, 10, 20, 10 over, so 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, like that. Okay. So these are the things. So if you look at that, below is a graph from 1990 to 2000 he gave. So let us see what is the question that he's asking. What is the smallest increase in the number of employees between 1990 and 2000? See, to some extent it was increasing and afterwards it was decreasing. You see, it's going on increasing. After that, the number of employees started decreasing and finally stood at 10, 20, 30, 40, 50. So at 50, the final count stood. Okay. So let us see what is that he's talking about. So smallest increase in the number is what? So 1990, there were 5 employees. From there, it increased to 10 in 1991. So the smallest increase is 5 between 1990 to 1991. So option is A. Please note it fast. Good. Okay, children, let us go to the next question. So the information is same. Question. What is the least decrease in the number of employees between 1996 to 2000? So number of employees in 1997 were 110, and to 1980, if you see, uh, the number of employees 1997 to 1998, if you see, it decreased from 110 in 1997 to 80 in 1998. So difference is 30. So option is A. Please note it fast. Let us go again. The same data, question changes. Okay. So what is the question? Let us see. What is the increase in the number of employees between 1990 to 2000? So final leftover count minus the initial amount. So final leftover count was 50. We have pointed out there. Initially, we started with 5. So number of increase of employees between 1990 to 2000 is 45. Okay, children. Please note it fast. Option C. Okay, children. Let us see what is there in the next question. Again, data is same. So let us see the question. What is the smallest percentage increase in the number of employees between 1990 and 1996? So, smallest percentage increase is 10 in 1996. So, therefore, is increase by original number into 100. Okay. So, if you see this, so now here, look at this. This is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. Okay, this is 110. So in 1996, there is increase by 10 units from here to here. By original amount in 1995 is 10. So always when we talk about percentage, we'll take increase by original into 100. This is the thing that we do. So therefore, it is increase is 10 units by original is 110 into 100. So this is what we have done here. So therefore, it is 9.1 percentage, option C. Please note it fast, quick. Okay, children, let's move to the next question. Again, data is saying, what is the largest percentage decrease in the number of employees between 1996 and 2000. So decrease is in 1998 from 110 to 80. By original was 100. So 30 by 100 into 30 by 110 into 100, which is 27.3%. Option A. Please note it fast. Okay, let us go to the next question. What is the largest percent decrease in 1996 to 2000? This we have already done it. Let's go to the next question. The data is saying, what is the percentage increase in the number of employees between 1990 and 2000? So percentage increase means what? Total increase by original into 100. So total increase is by 50 units, 1990 to 2000, minus the original amount was 5, by original number is 5 into 100. So that is 900%, option B. So please note it fast, quick. Okay, let us go to the things. Histogram below shows cell phone ownership by grade and gender in Emily's school. So look at this. Dark one is girls, black one, and the lighter one, gray one is boys. So, it's really in a lighter tone. Girls are working on mobiles more than boys. The trend that is shown here. So grade 1, grade 2, grade 3, grade 4, grade 1, grade 2, grade 3, grade 4, and grade 5. All grades, girls are using mobiles more. So now if you see grade 1, 10 girls, if they are using mobiles, then maybe approximately this is 5 boys. Okay. In grade 2, 20 are using, and boys 15 are using. And in grade 3, 25 girls are using, and this is approximately 18, if I'm right, 17 or 18. So in grade 4, 30 girls are using, whereas number of boys could be 21, approximately 21 or 22. So in grade 5, 35 girls approximately are using mobiles, and around 30 boys are using the mobiles. So let us see what is the question that is asking. If there are 80 students in third grade, approximately, what percentage of them have cell phones? So we see 80 students, he says, means boys plus girls is 80. In which grade? Grade 5. Okay, 35. So let us look at that. Third grade, not grade 5. Third grade, okay. What percent of them have cell phones? So now look at this. Total boys and girls together, there are 18 plus 22. who have cell phones, and total number of students are 80. So the percentage of students who have cell phones is students who have cell phones by total number of students into 100, that is 50. So this is option B. Please note it fast. Okay, let us see what is there in the next question. Again, the same data, information about the same kids and the things. What conclusions can be drawn from the histogram? ABCD options again. As fractions of the total student body, uh, the fraction of girls with cell phones is larger than the fraction of boys with cell phones. More students in grade 6 than 5th grade have cell phones. That is not right. Girls use cell phones more frequently than boys. Uh, so this is appearing to be the right one. Uh, uh, B, it is not right. So give girls use cell phones more frequently. Means the number of girls who have cell phones is given, but how many hours they are using is, or how frequently they are using is not given. So option B is more right because more girls have cell phones than boys. C is just apprehension or an imagination. So D is the right option of all. So please note it, please. Okay, let's go to the next question. So this is a graph, pie diagram, which has given some information. So 610 to 700 means 90. 710 to 800 is 90. 200 to 400 is 200. 410 to 500 is 90. 510 to 600 is 90. So this information is what? SAT math scores at Cedar Lane High School is this information. So somebody who scored um, between 200 to 400, that 10 percentage. Who scored between 410 to 500 is 15 percentage. So 510 to 600 is 30 percentage. and 610 to 700 is 25%. So let us see what is that he has asked. He has given some information. If there are 72 SAT math students between 510 and 600, how many SAT math students scored above 700? So let us get the percentage first and uh, what is the total number of students. Okay. So the percentages up to 700 is sum of all the things that I've given. So that is equal to 100. So it's equal to 20%. Now, if n represents the total number of SAT math scores, then 30% of n is 72. 30% of n is 72 because 30% is scored score between 510 and 600. So therefore, it is 72 divided by 30% is 0.30. So that is 240. That is 240. So since 20% that we got it here, since 20% of 240, we need to find out. So that is 20% is 20 by 100 is 0.20 into 240. That is 48 students scored above 700. Above 700. So that is option is B. Please go it fast. Okay, let's go to the next question. So it's the same data. We got x as 20. Okay, so let us see what is the next question. Same school's data that is. So 20% of students with SAT math scores from 610 to 700 received college scholarships. If there are total 240 SAT math scores, total 240 SAT math scores, and how many students with SAT math scores from 610 to 700 received scholarships? So 25% of 240 SAT math scores are from 610 to 700. So 25% of 240 is 1/4 of 240, that is 60 students. Okay. But out of this, it should be 20% because they actually got it as 20% if you remember. Okay. So 20% of 60 I should take. So 20% is 20 by 100 into 60, that is 12 students. So 12 students is option A. Please note it fast, quick. Okay, children, let us go to the next question. So let us see what is there. It refers to this graph. So, question, how much money is invested in the municipal bonds? So if you take the graph, total should be 100%. So in that, X is unknown. If you find out X value, these are two cases. 4X is 24. So X is 6%. X is 6%. Okay. So now we should calculate the number of bonds. It's 3x percentage, that is 3 into 6 is 18% have municipal bonds. So of the investment portfolio. So the amount invested in that is 18% of total amount. So that is 45,000. Hence 45,000 is invested in municipal bonds. So that is there in option A. Okay, please note it fast. Okay, so we close here today's session here. Hope you understood the concepts. They were all the basic concepts which were used before, and only some data is given, only that we have analyzed and worked on with the given information and the uh, accuracies, what it is. So there were certain approximations we made. So even that situation can face in an examination. So where you should approximate to the nearest value and answer the things. So therefore, you should be a bit careful in such cases uh, so that you don't commit mistakes. And wishing you all the best of luck and hope that you do good. Thank you and have a great day.